starts the recording. So your final, Mr. Simon and I will meet today, hopefully finalizing it, or at least the idea behind it, what we're doing in the formatting this week. I'll let you know when that is decided. For the rest of the semester, we're finishing up Asteroids. You have your coding back problem sets due Friday weekly until then. What else? Grading, it's gonna get caught up soon. Asteroids Part 1 has not been graded just yet. Neither has, no, did I grade the problem set? I didn't grade the coding bat problem set yet either. And any assignment you can redo, resubmit for full credit. Just send me an email. Questions, concerns? Ask them now. I think those are the big announcements from my side. All right. So here is the presentation on Asteroids Part 2. Asteroids Part 2 has you working on this kind of output. Notice the new additions. You have little rocks floating about. Notice their movement patterns. They build on the floater class, but they do things a little special. We'll focus on this asteroid here on the left, where my mouse is trying to follow. Notice that asteroids move, and they also turn. Right? This one's turning clockwise slowly when the GIF resets. And then this one here rotates counterclockwise. Okay. Notice that's how they're different than regular floaters. They're different than spaceships in that regard. No keys need to be pressed. They spawn themselves to the screen and then float around, turning in some kind of direction at various kinds of speeds too. Right? Like this one's kind of slow, and then you have this bigger one that starts off over here, moving kind of fast. Zoom. Okay. So these features are what make asteroids unique. You're going to reuse a lot of the code from the floater class, just like you did in Asteroids Part 1 with the spaceship. So to begin this assignment, we think about what components go into the asteroid class. So you're going to open a new PDE file. You're going to start making these things, and I already tell you that you're going to have a new member variable exclusive to the asteroids class, and that is called rotation speed. Rotation speed is going to be positive or negative. Positive means it spins clockwise, negative meaning it spins counterclockwise. The magnitude or the number value of it will control how fast it goes about. Okay, so this one variable, this one double, controls direction and like the speed, right? Direction and magnitude. The constructor, every class needs one of those, even if it's inherited, even if you inherit some features from something. Every class needs a constructor. And we'll talk about the move function today, which will be overwritten. Notice the behavior is special to an asteroid, so we have to tell it, do these things. You're special in these ways. So to begin, don't forget to add the private keywords, as those, that's the meaning of encapsulation. From this point on, you always have to have public or private in front of your member variables, your function definitions for objects. Okay, so this slide is a great starting point. By the end of today's class, after today's lecture, you should be able to create a single asteroid. On Tuesday, so that's tomorrow for us, we will talk about an array list, and that will get you multiple asteroids. And then you can get a head start on that by working on the problem set that's due this Friday. It's kind of simple, works you through some of the basics of array lists. So as a reminder, notice that asteroids look different. We use the coordinates to define an asteroid space like so. Here, remember the coordinates start in the upper left, go clockwise. Half of them should be negative. The center is at 0, 0. Assume that the direction it's pointing is to the right, which is 0 degrees. Okay. So here's a helpful example to get this kind of asteroid mapped out here. There is some creative liberties you may take when creating an asteroid, but be careful when doing so, as you don't want your asteroids to be particularly spiky or very, actually I think that's a bullet up here, right, or super tiny. So in this example, notice they still maintain like their, like they can't cross, they have, what do I want to say, they're like solid, it's a blob. Okay, so it still looks like an asteroid. So be careful when using random numbers if you are to do so when making your asteroid. Yep, moving on. So, vocabulary review. We have inheritance, and with inheritance comes this idea of a superclass and a subclass. The superclass has many names. It's also known as the base class or the parent class. I like the last analogy about parents and childs or children. So the spaceship, because it extends floater, the spaceship is known as a subclass, and it also has other names, the derived class or the child class. The main one to remember is super, as that's the keyword we'll be going into detail in the coming slides. Another reminder, when trying to map out visually these inheritance relationships, we use this little arrow that's read is a. So here, asteroids is a floater. Asteroid extends floater. The derived class points to the base class. The child always points to the parent. The subclass always points to the superclass. So remember that. That's how you read these arrow diagrams. A subclass is a superclass, is a. The other helpful reminder on why it points opposite to the way we think it does, like why do the parents not point to the children? All floaters are not spaceships, but all spaceships are floaters. Yeah, all asteroids are floaters also, but not all floaters are asteroids. Notice that this, if it were pointed the other direction, it would imply something that is false. Okay, so here's the new stuff. We have the super keyword, and there is the super, the function, specifically the constructor, and super, the keyword, which refers to the parent object. Okay, so the first one, super with parentheses, that is a call to the superclass constructor. It calls the parent constructor. It calls the base class constructor. Notice here there are no arguments. It's the default no argument constructor that's being called. Versus super with a dot, that accesses certain methods of the parent class. So for example, super.move in a spaceship would refer to the floater's move function. You'll be using this in your asteroids because the move class needs to be overwritten. And I'll show you an example of like why we need to use that in the coming slides. But know the difference. Parentheses is constructor. Dot means I'm going to use the member methods. So in a bit more detail, spelled out for you, super with parentheses, that's the base class constructor. If you had a derived class, so that's like spaceship, if you had nothing inside the constructor, what's being hidden from you is actually an invisible call to the no argument default constructor of the base class. In this case, it was the floater. Right? That's what allows your asteroid program to still run, even if you have an asteroid, or sorry, going back to the spaceship example, the spaceship constructor, even if you leave it blank, it would still make something. It would create a floater, and it would still work, even if you had nothing inside. Yeah. The second point, super dot, okay, and the name of some method. So this is the particular use case. You can use the method in the superclass to gain access to private variables that would be otherwise inaccessible. I'm like thinking, when is that necessary? I don't remember in my practice, but here in the coming slides we do have an example of one. Take a look at this. We have a generic subclass and superclass. Bob is an example of the subclass, which extends the superclass. Notice down here inside the subclasses constructor, we want to override or overwrite my num to be equal to whatever I tell it to be. Okay. My num is a private member variable of the superclass, and this kind of call, trying to pass in this one argument constructor, causes an error. It doesn't let you do so. My num is private, so the subclass can't do anything with it. Hence the use of like protected in the floater. Yeah, that's one way to like avoid this problem. But here's another way, using the super with parentheses. So code-wise, the super class and the setup is exactly the same. Then the one change is what happens down here. Okay. Super and num is passed in. What's going on here? When we call the subclasses constructor, we pass it in a number. That same number of 3 is being passed in. And then it calls the superclasses constructor passing in this number num. So then it goes here and reads, okay, now I can assign my num to be num. This is legal. The better use case, I think, with the parentheses here. So this is the main point, I think, from using the super keyword, is when overriding move. So fundamentally, the asteroids turn when they move. You need to implement that. So already you have a turn. Yeah, that comes from the floater. You used it when in your spaceships. Now we turn it by said degrees. And then you think back, oh, we have rotation speed that's already saved. That's going to be a member variable. I already told you in slide 3 that you need to use. That's where this part comes in. Okay, if it's positive, it'll rotate clockwise. If it's negative, counterclockwise. Great. And now comes the complicated part. They move just like a normal floater, and already that should raise some alarms in your head. Like, okay, floater, I already have a lot of code from there. How do I utilize it? First way is thinking, okay, I can copy and paste the code from floater. Okay, all that code you could copy and paste into the asteroids move function. That's tedious, right? That's copy and pasting code. We're better than that. We know things about objects. So there's a better way. And specifically, we need to call the move function inside the floater class. And what's weird right now is if you're thinking, okay, I can just call move parentheses, that won't work because you'll call like the asteroids move class, so it becomes a recursive call. You're calling a function inside itself, and it doesn't know when to stop and doesn't know how to process that. So you've got to add in a more specific keyword. You need to say, I need to access my superclasses move function, not the move function that belongs to me. Right? There's 2 moves right now. Move from floater, move from asteroid. And right now we want to use the floaters move class inside of the asteroids move function. I think I said a wrong word there. So notice what I want to get to is super.move. This calls the floater class's move function, which is the vanilla like wrap around, go in the direction that you're pointing, so on and so forth. So in just 2 lines of code, this is what the move function for a single asteroid looks like. Okay. All the slides we talked about today lead up to this one, super.move. The constructor, when you would use super with the parentheses, when you would use that constructor, I'm not so sure about. But I think this use case is most useful. All right. And so the last slide is, because you introduced and you're building on stuff from part 1, you need to add in asteroids.pde into your index.html. In part 1, because you already had asteroids game, floater, spaceship, and stars given to you, it's okay. It worked, right, when you uploaded it to GitHub. But because you added in a new object for part 2, asteroids, you need to add this thing in. So find this corresponding line inside your index.html in GitHub, add asteroids.pde to make sure everything's connected and working. So that's it for today's lecture. You can start your part 2 by making a single asteroid, spawning it to the screen, creating it, seeing it, that it moves, play around with the shapes, and then for us on Tuesday, so that's tomorrow, we will talk about array lists. So we can get used to making many of these asteroids to the screen. And they're a little bit different than arrays. We'll go over that tomorrow. Oh, I ended with 16 minutes. All right, questions or comments? All right, so formally, you can go. You're welcome to stay and work on these things. I'll sit around for another 10-15 minutes. See you later.